Okay, it's my pleasure to be here. So today I'm going to share with you research I've been doing with my very talented colleagues and students at the University of California, San Diego, in the lab we created 2 years ago, and we call this research cultural analytics. Well, briefly, you can think of cultural analytics as the use of techniques for data analysis and visualization, which are already widely used in sciences, business, and government, and other areas of modern society, but they haven't been yet applied to analysis of culture and cultural processes. So drawing on the incredible talents of hundreds of students in the media art at my university, as well as very advanced research in new visual technologies, we've been trying to figure out what kind of interfaces would you want to have to be able to analyze cultural trends, cultural patterns, or individual cultural artifacts. Right? So we had slides, we still use notepads, we use recent technologies such as Twitter and Facebook, but what are new types of cultural questions and concepts we can develop if we start using visualization? So whatever interesting things we can learn about the present if we analyze 20 billion photographs on Facebook, or perhaps 200,000 portfolios of professional designers on Carafloat and similar professional websites? Can we characterize variability and diversity of human media and culture in the same way in which biologists are doing it in relation to the biological world? Can we plot historical changes over time, how one sensibility, one style becomes another? And can we also describe cultural dimensions, such as rhythm, better, the dimensions for which we don't really have enough words in our natural language? So I'm going to show you, various experiments. Right now, the biggest data set we're working on is 1.2 million pages, which we collected over a few months, which come from, which correspond to 50,000 manga and graphic book titles. So it's approximately 10 million panels. And while, as you will see in a few seconds, you can do this research on your laptop, once you get into this big data, it's nice to have more faster computers. So we have a grant which allows us to analyze these data sets at the National Energy Research Center, and all the tools which we're developing open source and available for download now. And you can find more information and more examples of our work at softwarestudies.com. Well, I would not get this crazy idea to analyze patterns across large cultural data set if in 2005 I didn't have this amazing experience of seeing these new display technologies developed at my university. So I saw neuroscientists putting very high resolution images of human brain, and I saw astronomers putting very high resolution visualizations of development of the galaxies. And I thought, well, what about seeing how Renaissance becomes Baroque, or how modernism spreads around the world in the 20th century, or the changes in design sensibility in the last 10 years because of globalization. So here are some images of our software in development running on this display, which has a resolution of 36,000 by 8,000 pixels. And we also use it with students in our classes. So my presentation today will focus on different type of visualization techniques we can use for analysis of visual data, design, photography, art, games, websites, and so on. Well, conceptually, the simplest technique is something which we can relate to the history of panorama. So let's simply take a number of cultural objects which form a series, which have something to do with each other, and put them together. Okay, so we don't need to analyze things, use statistics, because most people don't know math and are not able to use these techniques. So let's say we can use purely visual techniques to understand cultural patterns. So this summer, Google made available all the covers of Time magazine, published from 1923 until now. So that's 4,553 covers. So normally when you look at the images on Facebook, Flickr, iPhoto, and so on, all you can see is small number of images, and it's kind of difficult to organize them along different dimensions. So let's simply take these images and put them all together, all these 5,000 covers, in terms of their dates, and let's see if we're going to see some patterns. So I'm going to zoom out, okay? And you're learning a lot, right? You find out right away that the black and white didn't become color right away, but for a while, black and white and color, were intermingled. You also see this very distinct kind of color trends, which who knows why they're there, so now we have to investigate it. You also find that, contrary to what you may expect, that the aggressiveness, the energy of commercial culture, you would imagine would be increasing throughout the 20th century, and indeed the hue and saturations of covers are becoming larger and larger, but then, surprisingly, over the last 10 years, they drop down and the covers become monochrome. So this is the examples of these larger patterns which become very visible once you bring many cultural objects together. Okay. Well, let's think of another technique. So if you're still reading books as opposed to e-books for the next 5 years, sometimes we use magic markers to underline things, to reveal structure. So what if we use computers to similarly underline a structure or particular patterns inside a cultural artifact to make it more visible? So to do that, let's start with something which for most people would say is definitely culture. So let's start with Anna Karenina, and just to make sure, if you remember how it starts. So I basically wrote this program, took me about 2 hours to render the whole Anna Karenina as one page. And now we can ask computer, for example, to underline every time Anna Karenina speaks, so every time her lover speaks. And you can imagine applying more complex computer analysis to underlying themes, moods, and other patterns across the novel. Okay. So now, if we want to also reveal more of a structure, we can substitute the display of text by these abstract rectangles. So in this case, every time Anna Karenina speaks, it's in red. Every time, her lover Vronsky speaks, it's in blue. And as I said, if we want to go from the original artifact to more of a structure, we can simply ask the computer to change the strings into rectangles. Now we can also apply the same thing to Hamlet. So here's the whole Hamlet. Doesn't look that big actually. Right. Here it is, 33,000 lines. And in this case, I simply ask the computer to underline red every time, it's Hamlet says something. And then we can experiment further and by kind of completely getting rid of the text and only leaving with Hamlet remarks. So the idea here is to demonstrate that we shouldn't think of visualization, right, as the opposite of representation, as the opposite of photography, but in fact, there is a kind of continuum from the original full object to a diagram to an abstract representation of its structure. Well, the next technique I'm going to demonstrate is conceptually maybe a little bit more complex. So instead of displaying the whole artifact or all artifacts together, let's sample them, right? So as an example of this, let me close this down and open something else. Okay. I'm sorry I have to, use Photoshop and you have to wait because these images are so big. No other program was able to load them without crashing. Okay. Yeah, it's about okay, so this is a popular Japanese game called Kingdom Hearts. So we recorded a student, playing this game from beginning to end. So here, looking at 66 hours of a continuous gameplay, and we simply record video on the screen, and then we sample it at, let's say, few seconds per frame. Right? So if I zoom out, you can see that this is made from individual frames of a game. Right? And if I go back, you'll see particular color parts which correspond to the different worlds in which the character is moving through. And this is, let's say, the sequel of a game. So right away, even without doing any complicated mathematical analysis, simply visually, you'll see the differences, different color hues, different contrast, somewhat different design style. Okay. Now, let me show you that you don't need to use supercomputers, even though it will become handy to do this research. So this is a very kind of important film by Russian director Dziga Vertov, right, a pioneer of documentary and montage from 1928. So the film talks about industrialization, the building of socialism in the Soviet Union. It was made in 1928. So we can ask the computer to simply make a montage showing every single frame of a film, but what if we spend time, we can either do it by hand or with help of software, and detect the boundaries between the shots in the film. So I've done that. So the film has 654 shots, and here we have one, for every shot we have the first frame. Okay, so now we're going to ask the computer to put it all in a kind of matrix. Okay. And we basically reverse engineered, right, we reconstructed a kind of storyboard for this film, which immediately shows you various narrative, temporal, and editing patterns in this film. And those of you who know about the kind of Russian montage school would recognize, right, very particular editing structure. So you kind of wonder why film historians haven't been using these techniques for decades. I mean, wouldn't you want to see this kind of representation for every film you ever studied? Now, the next set of techniques. So far, all I've been doing is simply kind of visual manipulations of my original artifacts. Okay? But now, let's say I want to spend a little bit more time, and I'm going to manually annotate and describe and add metadata, right, to my cultural artifacts, and then visualize these patterns. Right? So let me show you some examples of that. Okay, sorry. Okay, that's fine. Okay, so these techniques are useful for one film, one video game, let's say one design, but will become even more useful if you want to compare and contrast, 2, 3, dozens, hundreds, millions of cultural artifacts. So as a demonstration, I here took 2 films by Dziga Vertov. So the same one I was showing before, and on the bottom, this is a visualization of editing structure in his more famous film, A Man with a Movie Camera from 1928. So in this case, the height of each bar so each bar corresponds to one shot. So this film has 1,700 shots, this film has 600 shots, and the height of a bar corresponds to the length of a shot. So we're visualizing editing structure. So right away, you see a substantial difference in editing patterns in these films, even though they've been made in 1928 and 1929, so very close to each other. So you can see how in this film, Vertov has these parts where he kind of goes from longer to shorter shots in an alternating structure. And I also use 2 colors. So the red corresponds to all the normal shots, and then the white corresponds to what today we would call special effects. titles, superimpositions, and so on and so forth. Now, we can also do we can add more colors. So in this case, the different colors correspond to annotations which somebody have done by hand, which show you, where for each shot you annotate whether it is slow camera movement, normal movement, fast movement, and by using different colors to represent this information, again, you can see different patterns in these films, and you can imagine applying this to many, many more films. Now, one of the interesting questions is, if you're doing this cultural visualization, shall you do something very objective, something neutral, more like statistical graphics, or shall we move towards doing more like artistic visualization, right? A new cultural field which became very influential in the last 10 years, where the form of visualization somehow reflects or corresponds to the subject matter, right? So I've been experimenting with different techniques, and of course there's nothing new under the sun. So 2 days ago I was at Museum of Modern Art in New York, and I went to see the great show about Bauhaus, and I saw exactly the same technique being used by one student at Bauhaus in around 1926 to visualize the patterns in music. So here I, let's say, rediscovered the same technique and applied it to a film. So in this case, we see a whole film, which has 5 reels. So that's why you have 5 rows, and the size, each circle corresponds to one shot, and the size of the circle corresponds to the length of a shot. Now, so far, we've been, let's say, describing the data, annotating it by hand, but why not also use computers to measure various visual dimensions and then visualize these dimensions, right? So we can literally measure hundreds of different dimensions, texture, color, composition, brightness, contrast, and so on. So the question is, what are the interesting, larger cultural patterns which can be revealed by measuring these, let's say, low-level visual dimensions in visual artifacts and then visualizing them. Yeah. Let me show you some examples. Yeah. So this is the same covers of Time magazine as before. But in this case, it's about close to 5,000 covers. But in this case, we simply have measured kind of bright contrast and hue, and plotted the covers in such a way that the covers which are more saturated, right, which are have more color, appear on top, and the covers which are black and white, more black and white, more monochrome, appear at the bottom, and we organized by time. Yeah. So you can zoom in and then explore this interactively and look at different patterns.
Professor?
Yeah, got it. Okay, done?
Well, I'll give you an extra minute.
Sure. Okay, perfect, so much. Now you can apply the same thing, for example, to Google logos. Okay, so Google made available all its logos, or at least whatever logos it made available on its website. So it's about 560 logos. So you can use these techniques to map a kind of variability, right, of a cultural artifact, such as a brand, right, the way brand appears in the same way in which, let's say, biologists can map variability of a species. So here we organized all these logos in such a way that the logos which are, every logo is a little bit of a variation, right, of original. So the logos which are very small variations appear on the left, and the logos, which are represent lots and lots of variation, lots and lots of difference appear on the right, and you can see that most logos are in the middle. So let me see if I can use the next 10 seconds to finish off and to maybe show you something a little bit different. Of course, you can also add time. So this is the animation which shows you the development of, let's say, career, a style of Piet Mondrian, right, a famous abstract painter. So you'll see the year in the upper left corner. And the computer has organized the paintings by visual similarity. So you can see how in the beginning like all the paintings are very similar to each other, and then at a particular moment, they're going to venture out as Mondrian explores a larger part of a visual space, of a space of possibilities. Okay, finally, how about the last one? Perfect, yeah, no, I promise. Okay, let's see. Okay, perfect. Okay. I mean, it's endless, right? So people often ask me, Lev, are you discovering some amazing new things about culture using these techniques? And I would say sometimes yes, sometimes no. But what's more importantly, every time we do this analysis, one of our kind of seemingly common sense assumptions about culture gets challenged. So let me finish you by showing how you can use these techniques in relation to interactive media, which of course is the important media of our time. So in this case, we analyzed 10 video games, so right, so each, which took one game from each decade. And the sample, of course, is not big enough to make any important kind of statistical conclusions, but it's simply a demonstration of what can be done. Right? So you have sample frames from different games. Okay, here we are. Okay. But what's more important is the graph on the right side, where for each game, we simply plotted the part of the game which is, let's say, kinetic and mobile, where you're moving around, you're shooting, going for space, discovering things, right? And this appears in a dark gray. Sorry, this appears in a kind of white color. And then the part of a game which is, let's say, more cognitive, which is more static, where you're loading menus, making choices, not moving around, appears in dark gray. And what you can see is that the proportion between these two parts of a gameplay varies tremendously from game to game, right? So the media, right, and we ourselves often think of games as very kinetic, right? It's about constantly pushing a button or a joystick. Well, it actually turns out that there's an incredible sense of variability, and that in some games the kinetic part is very, very small. So this is a very, very small part of what we're doing. As I said, the tools to do this work are available for download, and I hope you'll join us and discover and make your own discoveries about the culture of the past, the present, and maybe the future. Thank you so much.
Thank you.